Well, good morning, guys. It's time for a rainy day project. So imagine this. You're pulling a trailer over one of the highest mountain passes in the Canadian Rockies on the hottest day of the year. And you begin to hear a squealing sound from the front part of the engine. You pull over and think it's coming from the AC clutch pulley or the AC compressor. What do? Well, this happened to me last summer. I was 1,000 miles from my tools. I was on a deadline and I didn't want to have to stay in a hotel. And so I pulled over to the nearest repair facility, and they gave me a short serpentine belt bypassing the AC compressor. Today I'm going to try and sort out the diagnosis. So my first challenge is to get the clutch pulley off and try and decide where the bad bearing is. We need to get this nut off. You can see that it's already had a little bit of use there. I think the previous mechanic gave it a go to try and remove it. Now Chrysler has some special tools that go into these 3 holes here. And I'm going to make up a tool to try and do that very same thing. So here's some 4-inch flat tape that I had sitting around. Now if you look carefully, you can see that I put 3 center punch holes. Now drilling this hole wouldn't be easy because the 2 holes go through each other. Now I'm going to tack this into place. This is 332/60/11 rod. Now the heads of these bolts are in the way, so I need to trim them down. So here's a final shot of this tool that I quickly made. 1/4-inch by 3/4 bolts, welded in place, the hole cut using a cutting torch, and now I can hold the AC clutch pulley in place while I spin that center nut off. So it didn't take much. You can see I've got them in there just with 2 bolts. I didn't need to do all 3 of them. So once that nut is off, then I just take 2 screwdrivers and I rock this back and forth gently and just walk the clutch page off. See what I'm doing there? Once that's off, you can see we've got a snap ring we've got to deal with. 2 little holes right there and there. Show you how I've got this. This is a 3-jaw puller. And there's not much room with this cowl. I could have unbolted the AC pump and lifted it up a little bit, giving myself more angle, or I could have taken the cowl and the fan off, but doing that in the Dodge is a little tricky. In any case, it does seem to be coming, and so I'm just going to gently pull this off. Okay, next is the electrical wiring, and I've taken off the 2 fuel injector nuts to get better access to this. This connection, you take out this little red retainer clip, and then once it's out, these 2 pull apart. Once the retainer clip is out, there's no other snaps. Next is this Phillips head screw right here, and it seems a bit tight, so I'm just going to use an impact so I don't strip it out. Now, if you look at the coil here, you can see all of this rust heat damage on the outer aspect of the coil, so clearly I've overheated it. Now I need to get the coil off, not just to replace it, but also to inspect the felt cover in the back to see if my compressor's been leaking. And the real question here, of course, is whether or not the compressor was leaking, which caused the overheat condition and then destroyed the bearing, or whether this is a bearing problem from the beginning and the heat was all secondary to that. Now my next step is to get at another snap ring, and it's down there. Well, it was too much of a pain to get that last snap ring off, and so I'm going to do what I probably should have done earlier in the adventure, is take off the air filter housing and then the radiator fill tube and give myself better access, and then pull the compressor up and out so I can get at that last snap ring. There it is there. Now that the snap ring is off, let's lift off the coil. And there it is right there. Okay, so here it is now with the coil removed. And I'm not seeing any evidence of oil tracking. The main worry, of course, here is that the compressor overheated because it was leaking oil at this seal here. But I'm not seeing any evidence to support that. Okay, one other thing we noticed on pulling this back is when you look at the base of the thermostat, you can see there's a bit of crusting right in there. And I think I've had a bit of a coolant leak. Okay, here's where we are so far. I undid the compressor enough to swing it over to here, and I've taken out the alternator, and you can see right there at the base all that crusting. So now I'm going to take off that heater hose. I'm going to be really careful not to knock off that sensor. I presume that's a temp sensor. And then we'll undo the bolts and clean it all up. I'm just about to blow it off with compressed air. Okay, I replaced the gasket for the thermostat and replaced the heater hose in that area. Now I'm just using a boreoscope just to make sure that my repair worked. I've run the vehicle through a number of cycles. A little bit of rust there, but really there's no evidence of coolant leakage ongoing. So let's look at how this all works. We've got three elements. We've got the clutch plate, and that's tied to the shaft of the compressor via these splines. So it only turns when the compressor is turning. The second element is the pulley, and it's driven 24 hours a day by the serpentine belt. It always spins when the serpentine belt is spinning. But there's a bearing here allowing it to freewheel when the compressor is not on. And the third is the coil. And all the coil is an electromagnet. It's fixed to the housing of the AC compressor, and so it only activates when the AC compressor is on. So these fit together like this. And so normally, when the compressor is not on, the pulley simply freewheels. But when you turn the compressor on, when you turn your air conditioning on, what happens is the coil is activated and turns into a big magnet, and it sucks that plate in, providing enough friction so that the pulley is now turning the compressor. That's how it all works normally. Now let's look at these a little more closely. So the AC clutch plate, aside from a bit of rust, seems to be okay. And I know that the device was functioning normally when my bearing failed. And so that part seems to be okay. The second is the bearing. And the most obvious thing here is if you look there, that is a completely seized bearing. You can see the ball bearings that are in there. The outer aspect of that was completely worn off. And if you look closely, you can see evidence of heat injury to the inner race of that bearing. And so that bearing is completely frozen. I think that's the cause of why this all failed. Here's the other side. And then we've got the coil, and as I mentioned before, there's evidence of heat damage here on the outer aspect of the coil. Let's see if the coil still works. All right, now let's test the coil electrically. I'm going to put 12 volts across the coil and see if I can generate magnetism. With no current flowing, it's not magnetic. Now let's hook up the 12 volt battery. It's about 36 ohms, so I should be in the ballpark of about 3 amps. So here's the test, and voila, magnetism. My induction ammeter is measuring 4.1 amps draw. It seems to be steady. So electrically, at least, the coil seems to be good. Now, ideally, I'd like to replace it because of this damage along the anterior surface, but I'm having some trouble finding the right parts. Well, here's something I didn't know about clutch pulleys. Sanden, who make my AC compressor, experimented with dozens of models of clutch pulleys over the years, each model unique and not necessarily interchangeable. There are those with splined or keyed shafts, different numbers of grooves in the belt, different diameters, and different distances from the pulley to the primary bolts. So finding a replacement that will fit my shaft is not so easy, and the expense of doing so gets close to the cost of a whole new compressor. Ricky Coleman from AC Parts Warehouse threw me a lifeline today. This is just the defective part, the bearing. So I'm going to try and carefully press the old bearing out, taking as much care as possible not to do damage. I've cleaned up this bearing, and I'll give you a close-up view here. The big problem, of course, here is that I hope when I push it out, that I don't only partially get it out and it ends up being a mess and maybe even breaking the pulley. And so that's the edge of the bearing right there. It has to come out that way. Looking over here, you can see that the bearing is staked to the wall of the pulley. And so I'm taking a Dremel tool and I'm grinding off the stake marks to make it easier for the bearing to slide out. Alright, I think I'm set up to press this bearing out. I'm going to use a socket to do the middle part, and I'm going to do it upside down mainly because it's easier that way. So we're going to press it out this way from the bottom up, and that socket is nicely centered in the middle. And I've got this length of pipe that's going to be nicely centered on the outside. Seems to be coming easy. Here's a shot of what it looks like with the bearing out. You can see there's been a bit of temperature discoloration on the outer race there, but I don't think there's going to be anything that's going to limit my ability to press in the new bearing. Word of caution, make sure when you press it in you've got adequate support on the outer ridge here, because if you don't do it properly, this area is likely to break.